The idea of domain has been a key one in this class. When we have a square root, you want to make sure that that 3x minus 5 is greater than or equal to 0. So adding 5 and dividing by 3 tells you that x must be greater than or equal to 5/3. In interval notation, that would be starting at and including the 5/3 and continuing on up to positive infinity. Notice that when we had the square root, we used greater than or equal to with our 0. Now, moving on to part B, we can't divide by 0. So 3x minus 5 cannot equal 0. Now I'm cheating here when I solve this inequality using properties of equations. This isn't an equation, but I think you will all agree that I'm allowed to do it. I'm just mentally making sure you know that we're not allowed to. So x is not equal to 5/3, which means x can be any other value, starting at negative infinity, going up to but not including 5/3 on the left, and then all values to the right of but not including the 5/3 on the right. When you have a logarithm, then you need to make sure you do not have a negative inside the log, nor have a 0 inside the log. So this time we're going to have a greater than 0 without the equal sign. So this time we want to make sure that x is greater than 5/3. So in interval notation we will have from 5/3, which we do not include, on up to positive infinity. And now in this final domain problem, with a square root again, we need to make sure that x squared minus 25 is greater than or equal to 0. But this time we have a quadratic inequality, so I'm going to factor this using the difference of two squares into x plus 5 times x minus 5 greater than or equal to 0. And our two critical values will be negative 5 and positive 5. And again, just as we saw on a problem earlier in this review, there is no parabola, but we're going to pretend there's a parabola here for the purposes of this quadratic inequality, and this x squared would be a positive x squared. That's why I do a parabola going upwards, and we are interested in when it is at or above the x-axis, which is off to the left or off to the right. And so we can write our solution set as x element of negative infinity up to and including negative 5 united with the interval including the 5 and all values to its right. Find the sum of the first 5 terms of this geometric sequence. Since it's geometric, I like to do everything without a formula. I'm just going to start with my first term, 6. Each term after it is going to be found by multiplying by negative 2. So multiply by negative 2 to get negative 12, multiply by negative 2 to get 24, multiply by negative 2 to get negative 48, multiply by negative 2 to get positive 96. Notice 1, 2, 3, 4, 5. We've got all of our terms. Add these together to get 66, and there's your sum. Find the sum if it's possible. Okay, well, we got to see. We notice it's an infinite geometric series. We see that we're multiplying by negative 3. And the answer here is no, there is no sum possible. This diverges. The value of r must be between negative 1 and positive 1. If it does not fall within that interval, then you do not have an infinite geometric sum. Okay, find the focus and directrix. Well, we see that y is squared, so it's not a function, so it opens left or right. And because of the negative value on the right, that means this is going to open to the left rather than to the right. We can read the value of the vertex by changing the sign of the numbers from the parentheses there. So the vertex is going to be located at negative 2, negative 3. Don't go with the y value first. Make sure you go to the x parentheses first. Since we have 4p equal to negative 12 there, that means p is going to equal to negative 3 when we divide by 4 on each side. Now p represents the distance from the vertex to the focus on the left and the directrix on the right. So we are going to move 3 units to the left to find the focus. And so negative 2 take away 3 will be negative 5, comma, negative 3. And the directrix will be a vertical line, therefore it will be of the form x equals, and we'll be adding 3 to the negative 2, so that'll be 3 to the right, x equals 1.